Welcome to this amazing course on Kubernetes. This course will help you master Kubernetes by learning to deploy amazing microservices built using Spring Boot and Spring Cloud to the Google Cloud Kubernetes engine. I am Ranga Karanam. I am the founder of In 28 Minutes and creator of some of the world's most popular courses on Java, Spring Boot, microservices, full stack, and the cloud. I've helped more than 300,000 learners across the world acquire new technology skills. At last count, I've had about 30,000 five-star reviews on my courses. I love programming and I believe Kubernetes is among the top skills to acquire for Java developers today. I'm a great believer that the best way to learn is by doing. And in this course, you'll learn the fundamentals of Kubernetes by building and deploying amazing Spring Boot and Spring Cloud projects step by step. We'll start with learning the basics of Kubernetes: cluster, nodes, deployments, pods, replica sets, and a lot more. You'll learn the best practices in using Kubernetes, deploying several Spring Boot and Spring Cloud projects. You'll understand the challenges in building microservices, and we will also look at various solutions which are provided by Kubernetes. We will deploy a fully featured microservice to Kubernetes. We will implement all the popular microservice features: autoscaling, service discovery, load balancing, centralized configuration, distributed tracing, and monitoring. All these with Kubernetes. On this awesome journey, you'll also learn to implement service mesh with Istio and create Helm charts to deploy your Kubernetes applications. We'll be using Maven as our build tool and Eclipse as our IDE, and we expect you to have good knowledge with Java and Spring. We'll help you create a Google Cloud account during the course, to create which you need a valid debit or credit card. The complete source code, including the step-by-step instructions for the course, are present on the GitHub repository of the course. This course is everything you would need to learn Kubernetes. Kubernetes is one of the highest in-demand skills in the Java Spring Boot world. Start learning to build great microservices and deploy them to Kubernetes, and join me on this exciting journey right now. I'll see you in the course. Welcome back. I'm super excited to have you here and have the privilege of being your instructor for this amazing course. Let's start with an interesting story. A number of learners ask me what in 28 minutes means and where it comes from. I'm a great believer that if you spend 30 minutes every day taking a small step towards your dream, you will reach the top 5% of whichever career path you choose. And this belief in continuous learning is what made me choose the name in 28 minutes. And the fun fact is that I could not afford to buy the domain names in 30 minutes and in 29 minutes, and I had to settle for in 28 minutes. Not bad, isn't it? I'm a great believer that the best way to learn is by doing. You do not learn to drive by watching Tom Cruise drive at amazing speeds. You have to do it yourself to learn. The same applies to learning programming and learning to develop and deploy applications. You have to get your hands dirty. That's how you learn the most, and that's how we design our courses. So what are you going to learn and what are we going to build during this course? During this course, we will learn all the basic concepts about Kubernetes by deploying several applications to Kubernetes. We will start understanding the fundamentals of Kubernetes by deploying a Hello World REST API. After that, we would move into deploying a web application which uses H2 as a database, and after that, we would actually move on to a web application which talks to a MySQL database. After that, we would move into the exciting world of microservices. We will learn the basics of service discovery and load balancing, which is provided by Kubernetes by using the projects 4 and 5. After that, we would use the project 06 Currency Conversion Microservice Cloud to integrate our microservice with Spring Cloud and look at all the features that Spring Cloud provides, especially with respect to load balancing and centralized configuration management. After that, we move into the world of Google Cloud Stack Driver. We will use projects 07 and 08 to explore Google Cloud Stack Driver and explore the different features related to logging and tracing provided by Google Cloud Stack Driver. And then we step into the world of Istio, a service mesh with the projects 09 and 10. With its sidecar pattern, Istio provides amazing features on top of your microservices. It enables a number of release strategies like blue-green deployment, canary deployments, and a wide variety of stuff. It also enables distributed tracing. We will explore distributed tracing using OpenAPI with Jaeger. As far as I am concerned, the section on Istio is my favorite section of this course. And after that, we would move into Helm, where we would automate our Kubernetes deployments using Helm. So this is a course where we will explore Kubernetes and all the features around Kubernetes. And as a student of the course, the most important resource for you is the GitHub repository of the course. The GitHub repository of this specific course is github.com/in28minutes/Kubernetes crash course. I would recommend you to bookmark this GitHub repository because we would make use of the GitHub repository for a lot of things. You can also find the GitHub repository link in the resources section of this video. What are the recommended software for use in this specific course? We recommend using any versions which are greater than or equal to Java 8. And we would recommend you to download and use one of the latest versions of Eclipse Java EE. If you do not have Java 8 Plus or Eclipse installed, you can follow this playlist and install those two things. All the other stuff we will install as we go on further in this specific course. If you have any problems with the installation or if you face any problems during the course, we also have a 50-page troubleshooting guide with solution to more than 200 frequently asked questions. Congratulations! You are joining 300,000 learners having amazing course experiences from in 28 minutes. Enough talk. Let's dive straight in and start this amazing journey on Kubernetes together. Welcome back. In this video, let's get a 10,000 feet overview of Docker, Kubernetes, and the world they are part of. Let's start with a simple question. Why do we need Docker? To understand the need for Docker, we will look at a simple scenario. You have a close friend of yours in your operations team, and you'd want to quickly deploy an application. You go to him and say, I would want to deploy an application. He asks you, hey, what's your Docker image? And you give the Docker image to him. And he says, I'll just run this command. So just types a few characters in, runs this command, and presses enter. Within a few seconds, you would see the magic unfold. You are seeing an application being deployed, and if you launch up the URL in the browser, you see that the application is up and running within 15 seconds flat. Now, think about this. Your friend from the operations team did not ask you, hey, what language did you build the application with? He did not ask you, what frameworks did you use? He did not ask you, what is the operating system where your application should be deployed on? He did not ask you, what is the configuration that your application needs? The thing is, he doesn't really need all that. That's what Docker enables. A developer builds an image, and you can run the same image wherever a container runtime is installed. You can run it on your local machine, in your enterprise data center, or in the cloud. Docker enables standardization of how you package and deploy your application irrespective of the language or framework which is used to build the application or the platform where you'd want to deploy the application to. Now, you guys are really happy with Docker and you keep the application running with Docker. Now, a couple of days later, you go to your friend in the operations team and now ask, hey, do you know if my application is still running? I would want it to be always running. And by the way, I'm expecting a lot of load this weekend. So I'll want to be able to increase the number of instances whenever there is a lot of load. And also you say there are a number of other applications coming up very soon. I want to be able to deploy and manage all that. Now, your operation team's friend gives up. He says, nope, that's not what Docker does. So you go ahead, research, and find out the brand new tool out there in the market, Kubernetes. So you are now the expert on Kubernetes. You have created an amazing Kubernetes cluster, which is nothing but a group of servers that are managed together, and you are now connected to the cluster. And it's your friend's turn to specify the requirements right now. He says, I want to quickly deploy an application with this specific image. You say, oops, that's easy. I just need to run a simple command and you are there. And by the way, it's not just one command. Actually, there are two commands that I would need to run to actually deploy an application and make it available to you. Now, your friend tells you, hey, I could have done this in Docker with one command. Kubernetes makes it complex. You are executing two commands to actually expose a deployment. Now, you tell him, hey, there is a lot of power to what we are doing. Wait and see. So you go to the browser, type in a URL and show him, hey, see this, the application is live within 15 seconds. You ask him now, what more do you want? Your friend says, I want 3 instances. You say, I'll just run one more command. And within 10 seconds, you'd see that there are a few more instances coming in. You can see that there are new instances because this last 5 digits are changing. These last 5 digits indicate which instance the response is coming back from, and you'd see that within few seconds we are getting responses back from different kinds of instances. And you can also see that the load balancing is happening automatically. The load is being distributed among different instances which are present in there. So you tell him, hey, see the magic in Kubernetes. With just 3 commands, we were able to actually create multiple instances of an application and also do load balancing. Now, your friend is still not satisfied. He says, I would want these instances to be running all the time. Even if one of the containers fail, even if one of the instances goes down, I would want other instances to come up immediately. And you tell him, hey, watch this. I'm executing another command. I'm actually deleting one of the instances right now. And let's keep refreshing. You can see that the application does not go down even if one of the instances goes down. And you would see that within 10-15 seconds, another instance of the application comes up. You tell your friend that, hey, Kubernetes does a lot of magic. You don't really need to worry about monitoring the application. Kubernetes does it for you. You told Kubernetes that I need 3 instances. Come what may, Kubernetes will try to ensure that there are 3 instances always running. Even if one of the instances goes down, Kubernetes does all it can do to bring another instance up. Within a few seconds, you'd see that the 3rd instance is up and running as well. And your friend has one last request. He says, I would want to increase the number of instances when there is more load. During the weekend, I'm actually expecting a lot of load, but thereafter, I think the load would immediately go down. And also, during the day, I'll have a lot of load, and during the evening, there will not be any load at all. And I don't want to manually increase the number of instances and decrease the number of instances. You execute another instruction to auto scale and say, okay, done. I've executed the command to do that. Right now we can go up to a max of 10 instances, but you can quickly change that whenever you do want to. He's amazed with all the power of Kubernetes and he says, one more question please. I have one more requirement. I would want to make a new release without anything going down. I would want to go from 0.0.1 release of the application to 0.0.2 release of the application without anything going down. You tell him, hey, it's a little bit more complex than what we have been doing until now, but it's not impossible. You quickly go ahead, edit your deployment, you add a simple line of code in here saying min ready seconds is, you say 15 and say, and you'd save this and you tell him, I have a solution right now which works for 90% of the scenarios, and you go ahead and execute the last command to go to the new release, which is 0.0.2.release. And you would see when the whole thing happens, that the application remains up and running. So now V1 is live. That's the only application which is running right now. And you can see that the application is still up and running. And within a few seconds, you would see that V2 is live, and now load is shifting between V1 and V2. So, and after a few seconds, you'd see that V2 is the only application which is live. So we have switched off V1 and we are completely switched on with V2. Do not really worry if any of these concepts were new to you, you were not able to understand the terminology, or the commands seemed very complex. The idea was to show you what you can do with Kubernetes. And you'd see that by the end of this course, you'd be able to do this and actually a lot more with Kubernetes. It's my job to help you learn these commands and a lot more. Whatever you're seeing until now is the magic that Kubernetes enables. You could see that with just 7 or 8 simple commands, we enabled powerful features on our application. We made it auto scale based on the load. We were seeing that Kubernetes was automatically doing the load balancing between the available instances. We were also seeing the fact that Kubernetes is monitoring the whole thing, and when an instance goes down, it immediately brings another instance up. And we were able to easily release a new version of the application with zero downtime, and all these with 7 or 8 instructions. The amazing thing about Kubernetes is the fact that you can scale whatever you are seeing right now to thousands of microservices having thousands of instances in a declarative way. You tell Kubernetes, I need 100 instances of this microservice running, and you don't need to do anything. Kubernetes would make sure that it would happen. And on top of this, Kubernetes is cloud neutral. There are solutions provided by different cloud providers. AWS, Azure, Google Cloud, each one have their own Kubernetes solution, and you can install Kubernetes on any of these cloud providers. So if you are deploying your applications to Kubernetes, you can run in any of the clouds. You will learn all the magic about Kubernetes during this course with a number of Spring microservices. Now, where do these microservices run? You need a Kubernetes cluster or a group of servers. One of the interesting things about Kubernetes is that setting up Kubernetes is not easy. Creating and managing Kubernetes clusters can be really tough. And that's where we use GKE, Google Kubernetes Engine. GKE is a managed service provided by GCP. So Google Cloud Platform provides this managed service called the Google Kubernetes Engine. So we don't really need to worry about creating a Kubernetes cluster and maintaining it. Google takes care of it for us. And the amazing thing is we'll be using the same infrastructure that Google uses to run Google Maps, Gmail, YouTube, and Google Search. Are you ready for this roller coaster ride? Jump on, and I'll see you in the next step. Welcome back. Are you excited to deploy your first application to Kubernetes? Let's get started. Let me start with reminding that Kubernetes can be tough to get started with. There are a wide range of concepts you need to learn to master Kubernetes, like clusters, nodes, pods, containers, deployment, service, replica set, and a host of other features. And also, we are working with Kubernetes on Google Cloud Platform. This throws in a few of the Google Cloud concepts as well. Regions, zones, projects, compute engines. Some of these terms can be intimidating at first, but I promise by the end of the first 1 hour of the course, all these would start making perfect sense. Each of the concepts that we talked about are interconnected, and you cannot understand one without understanding another. However, the great thing is that we found a hands-on approach to break this down and make it really easy for you. We really believe that complex things should be explained by breaking them into small understandable chunks and explained in small practical steps. Our aim for the first section of the course is to deploy a simple REST API to Kubernetes. Now, what do you want to be able to deploy something to Kubernetes on Google Cloud? The first thing you need is a Google Cloud free trial account. The second thing is we'll create a Kubernetes cluster, and then we'll be all set to deploy our REST API. As we go through these steps, we will demystify all the important concepts and help you master Kubernetes. In this step, let's get started with creating a Google Cloud free trial account. Make sure that you are logged into your Google account and go to the website cloud.google.com. Once you are there, you can click the button Get Started for free. On the next screen, you get to choose your country and make sure that you read the terms of services and agree to them. This Google free trial account gives you $300 credit and also free access to a number of Google services for about 12 months. One of the interesting things is Google does not auto charge you after the free trial ends. That's cool, right? Now, when you click continue on this page, you'll land up on a next page where you need to enter a lot of information. You need to choose your account type, you need to enter your tax information. After that, you'd be asked to enter your address information. You need to choose how you'd want to pay your bills, and you can choose your payment method. You can enter your card details in here. While you are entering the card details, Google might want to verify your card, so they have different processes based on which country you are in. So make sure that you go through the verification processes. In some of the countries, they might even do a trial transaction to make sure that your credit card is valid. Once you go through all the payment details, you need to click the Start My Free Trial button, which is present on the screen. It will take a while for everything to be done, probably about a minute. And at the end of it, you should land up on a screen like this. Congratulations! Your Google Cloud account comes with 12 months of free trial for some of the Google Cloud services, and also it comes with $300 credit. So let's make the best use of it to learn Kubernetes. In this step, we quickly created our Google Cloud account. Let's get started with using it in the next step. Welcome back. While the creation of the cluster is in progress, let's look at a few fun facts related to Kubernetes. Kubernetes abbreviation is K8S. So if anywhere you are reading something and you see K8S, don't get stunned. K8S actually stands for Kubernetes. So K, 8 letters, and S. The next interesting fact is the fact that Kubernetes is pronounced as Kubernetes. 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 Say that a few times. Practice this a number of times. The next time you see a friend of yours saying Kubernetes or something like that, say, nope, you should call it Kubernetes. The next interesting fact is logo, helpsman. The logo of Kubernetes represents somebody who's providing direction to a ship. In olden days, on a ship, you had something like this to manage the direction of the ship. And this was the role of somebody called a helmsman. And that's what Kubernetes does. It manages things. And that's where the logo helmsman for the Kubernetes comes from. The last interesting fact is Kubernetes on the cloud. Different cloud providers provide different services for Kubernetes. Azure calls it AKS, Azure Kubernetes Service. Amazon calls it EKS, Elastic Kubernetes Service. And Google calls it GKE, Google Kubernetes Engine. Okay, that's end of the fun facts, and let's see if our cluster is ready. Cool. I see an icon saying the cluster is running. On the screen, you can see a little bit of generic information about this cluster. It has 3 nodes, it has 3 virtual CPUs, and it has 11.25 GB of memory. We saw that each of the nodes had 3.75 GB, and 3.75 GB into 3 is what you see here, 11.25 GB. Now, let's go inside where you can see some more generic information about this specific cluster. You can see which version of Kubernetes it is making use of. You can see the total size. You can see the location of where the master node is present, where the worker nodes are present, and a few other details about the cluster. If you go to the nodes, you can also see the details of all the nodes which are present. On the screen, you can see more information about the nodes. You can see that there are 3 nodes. You can see that some amount of CPU has already been requested on these specific nodes. You can see how much CPU is available, and also you can see how much memory is available for new applications on these specific nodes. Let's talk about something very important before we move into the next step. When we created the nodes, we created them with 1 vCPU and about 3.75 GB of memory. However, if you see right now, there is only about 2.75 GB of memory that is available on each of these nodes. What is happening with the rest of the memory? Who's making use of it? The answer is Kubernetes. Kubernetes needs to manage the nodes, and like every manager, Kubernetes takes a cut. It says, hey, I need to do a lot of work to manage these nodes. So reserve some CPU and some memory for the work I need to do with these nodes. In a later step, we will dig deeper into what kind of processes Kubernetes runs on these nodes. But at a high level, it's important to understand that Kubernetes has something installed on each of these nodes to manage them. In this step, we discussed a few fun facts about Kubernetes and saw that our cluster is up and running. Are you excited to deploy your first application to Kubernetes? Let's start with that in the next step. Welcome back. Are you excited to deploy your first application to a Kubernetes cluster? I am excited to get you there. Now, what do you need to do to deploy an application to a Kubernetes cluster? The first step is actually to connect to the Kubernetes cluster. How do we connect to the Kubernetes cluster? We are awesome programmers. We'll use command line. Typically, when we want to use command line, we would need to install a lot of software. However, Google Cloud really makes it very easy. It provides you something called Google Cloud Shell. Now, the first thing is make sure that you are inside the cluster. So over here, what I am doing is I am going inside the cluster, which we have created earlier. And what I'll also do now is to activate Cloud Shell. So there's an icon present down here to activate Cloud Shell. When you click it, you would see that the Cloud Shell opens up here. It would take a little while. If this is the first time you are launching a Cloud Shell, it might take a few minutes. So hold on while the Cloud Shell launches up and shows something like this. What I've done is I've customized my Cloud Shell. I'm using terminal preferences, color themes of light, and I've made the text size to large. Now, you can see that Cloud Shell takes a part of the screen. The rest of the screen is actually your interface for the Google Cloud Platform, and that's not really convenient for us to use. And that's why the way I prefer using Cloud Shell is its own window. You can click this icon which is present in here, which says open in new window. So this would open up the Cloud Shell in a new window of its own. Cool. Now it's launched up here. So what I'll do is I'll close the terminal down here. You'd see that once I close the terminal down here, I have to again click the icon to launch it up. So now we have the Cloud Shell launched up in its own window, and we have a complete UI for the cloud platform also available for us in Cloud Console. We want to connect to this cluster. How do we do that? Click the connect in here. I'll click the icon which is present in here to copy the command to click, and I'll run it in here. You'd see that this command is a Google Cloud command to connect to the cluster. So we are connecting to the in 28 minutes cluster that we created earlier. We are connecting to the cluster which is in zone US Central 1A, and you are using the project ID for the project that we have. The project that we are using is my first project. If I do OK here, this is the project we are using, and you can see that the ID for that course is actually solid-course-258105. So that's the entire command that we are executing to connect to the cluster. So now you can see that we are connected to the cluster. We would want to run commands against this cluster. How do we do that? That's where something called kubectl comes into picture. Kubectl is Kubectl. kubectl is short form for kube controller. Make sure that you remember this very well, because we would be using tons of times during this course. Kubectl is an awesome Kubernetes command to interact with the cluster. The interesting thing is kubectl would work with any Kubernetes cluster, irrespective of whether the cluster is in your local machine, whether it's in your data center, or it's in the cloud. Once you connect to the cluster, you can execute commands against any cluster using kubectl. Kubectl can do a lot of powerful things for you with Kubernetes. You want to deploy a new application, kubectl. You'd want to increase the number of instances of an application, kubectl. You'd want to deploy a new version of the application, kubectl. The awesome thing is kubectl is already installed for us in the Cloud Shell. So let's go ahead and type in kubectl version. Yep, it shows the client version and it shows the server version. The server version is the cluster that we are connecting the kubectl to. Now, we have launched up Cloud Shell, we are connected to the cluster, and we are ready to execute commands against the cluster. We want to deploy an application. How do we deploy an application to a Kubernetes cluster? Go ahead and type this along with me. Kubectl create deployment. Let's call this deployment as Hello World REST API. So we are going to deploy a REST API which has just Hello World in it. So Hello World REST API is the name that we are providing it. And I'll say -- image is equal to, we are providing the container image. What is the container image that we would want to make use of? Type this in 28min / hello world REST API : 1.0.0.release. So make sure that you are getting this right. Kubectl create deployment hello world REST API separated by hyphens. -- image is equal to in 28min / hello world REST API separated by hyphens : 1.0.0.release. Now you might be wondering, where is this image coming from? You might be wondering, what's this in 28min hello world REST API 1.0.0 release? What does it contain? How was it created? The thing is, this is the Docker image for the REST API that we would want to deploy. If you are familiar with Docker images, you would know that there are a few steps which are involved in creating Docker images and pushing out to Docker Hub. What we have done is, to help you get started quickly, we already created a Docker image for the Hello World REST API and pushed it to the Docker repo, which is Docker Hub. If you go to hub.docker.com/u/in28min and look for in28min / hello world REST API, you would see that there is a repository which is already present in here. And if you go to the tags, you would see that there are a few releases for these applications already present. The one which you are making use of right now is this 0.0.1 .release. We are right now trying to deploy this image. Now, don't really worry about the creation of the image. What we'll do is, for the subsequent applications in the course, we'll create Docker images, deploy them to Docker Hub, and use them from Kubernetes. For now, let's keep our focus on understanding Kubernetes. So let's keep going. Now, before we proceed any further, there's a small typo. It should not be 1.0.release. Actually, if you look at this is 0.0.1.release. So let's fix that. If you want, actually, you can find this command on the GitHub repository of the course as well. At the top, the exact command, you should find it down there, which you can use. Make sure that you don't have any typos. It's -- image is equal to in28min / hello -world -rest -API : 0.0.1.release. You can also copy the tag from here, so you can actually take the entire tag from here after selecting this. To make sure that you are not making any typos, you can also copy this and actually paste it in here and take the last part of the command. So that's where the entire image name is present. So in 28min hello world REST API is 0.0.1.release. Make sure that you don't have any typos and press enter. What would this do? This would deploy the application to a Kubernetes cluster, and it gives you a deployment ID. So it says this deployment is created. Isn't this awesome? Now, what we want to do? We would want to expose this deployment to the outside world. How do we expose a deployment to the outside world? We have another command, kubectl expose deployment. What is the name of the deployment that we would want to expose? Hello world REST API. That's the deployment that we would want to expose. And what we would want to do is we would want to expose it as a load balancer. So type is equal to load balancer, and we would want to expose it on port 8080. So let's put 8080 in. So kubectl expose deployment hello world REST API -- type is equal to load balancer -- port is equal to 8080. That's the command that we are executing. This would expose a service to the outside world. You can see that there is a service which is being exposed right now. Now we want to find out the status of creation of these. What we'll do is we'll go to the UI and check that up. So let's say OK in here. Let's go to service and ingresses. It's taking a little while for the page to load. Let's give it some time, and you'd see that it's creating service endpoints. Now, if you wait for a little while, you'd see that a OK button comes in. So the status is now OK. Hello world REST API is all available, and it says the endpoints is this. So let's go ahead and see what's available at the endpoint. Let's click the endpoint link. Cool, it says healthy true, and actually the REST API which is exposed from here is at hello world. So / hello world, and you can see hello world v1. Don't really worry about it for now. The important thing is when you execute this URL, you are getting a response back. The other URLs which are present in this specific service are hello world bean, which returns a JSON back. But the most important thing that we would want to focus on is the fact that with just 2 simple commands, we were able to get the entire thing working. We were able to pick up an image from the Docker Hub, deploy it to Kubernetes, and also expose it as a service to the outside world. Congratulations for successfully deploying your first application to Kubernetes. Time to celebrate? Yes and no. We have something working. That's really cool. However, we are not sure what's happening in the background. That's not really cool, isn't it? Let's dig deeper in the next steps. In this step, we did a lot of things. We started up Cloud Shell, we connected to the cluster, we created a deployment, we exposed the deployment, and we were able to finally see a working application. In the next step, let's dig deeper and see what's happening in the background. I'll see you in the next step. Until then, bye. We have an application running in the Kubernetes cluster. How did the magic happen? What's happening behind the screens? Let me start with a warning. Getting an application up and running in Kubernetes is the easy part. Understanding what's happening in the background really gets messy. There are tons of new concepts involved. So buckle up and let's get on the Kubernetes roller coaster ride right now. You'll see that there are a number of bumps on the way, but that's how things will remain exciting. Let's get started now. Let's go to Cloud Shell and execute a command, kubectl get events. You can see a lot of events have happened. The first events that you are seeing in here are all related to creating the cluster. This is the event where we started creating our application. You can see that there is a pod which was created. There is something called pulling an image which is happening in there, and it does a sequence of steps to start up a container. And after that, you'd see something called a replica set, you'd see something called a deployment, and finally you see something called a service. We created and exposed a simple deployment, and the Kubernetes magically created for us a pod, a replica set, a deployment, a service. Now, what is a pod? What is a replica set? Why are these being created when I create a deployment? What is a service? Kubernetes really likes to make things very, very complex. So complex that is very, very difficult to understand. I was kidding. Let's now break it down. Let's run a few more commands. Kubectl get pods. This would get all the pods that were created. So you can see that there was a pod which was created. It's in a status of running. Now we got the pods. What's the command for getting a replica set? Try and guess. Yep, Kubernetes get replica set. So the thing is, Kubernetes get is a generic command. You can use Kubernetes get to get a pod, get a replica set, get a deployment, or get a service. So you can do get deployment, and also you can do Kubernetes kubectl get service. So you can see that you can get details of different things by using the kubectl get command. We see the details of the pod, we see the details of the replica set, we see the details of a deployment, and we see the details of all the services which are present in here. For now, don't really worry about this Kubernetes service which is running in here. It's an internal Kubernetes service that we don't really need to worry about. But all the other things that you are seeing are related to the Hello World REST API. So the pod you can see is named Hello World REST API hyphen some characters. The replica set is also similarly named. The deployment is named as Hello World REST API, and the service is named Hello World REST API as well. Now, what do these do, and why do we have so many concepts? The important thing to understand is Kubernetes uses single responsibility principle. One concept, one responsibility. Each of these, a pod, a replica set, a service, and a deployment, have a very, very important role to play. When we executed the command kubectl create deployment, Kubernetes created a deployment, a replica set, and a pod. When we executed the command kubectl expose deployment, Kubernetes created a service for us. Each of these concepts have a prominent role to play in Kubernetes being very successful. Each of these concepts have one important responsibility that they do really well. And as a combination, they provide the important responsibilities of Kubernetes, which are to manage workloads, to provide external access to workloads, to enable scaling, and to enable zero downtime deployments. In this step, we understood the fact that there are a number of important concepts involved in how Kubernetes achieves its goals. Services, pods, replica sets, and deployments. Starting next step, let's dissect each one of these concepts and understand them in depth. Welcome back. In this step, let's start with understanding pods. Pods is the most important concept in Kubernetes. A pod is the smallest deployable unit in Kubernetes. You might think containers are the smallest deployable unit, but nope. In Kubernetes, the smallest deployment unit is actually the pod. Let's consider a question. I would want to create a container in Kubernetes. Can you do it without a pod? The answer is no. You cannot have a container in Kubernetes without a pod. Your container lives inside a pod. Now, what does a pod have, and why do we need a pod? Let's look at it in this specific step. Let's go back to our favorite Cloud Shell. I'll do a clear, and I'll type in kubectl get pods -o wide. Now, what are the details that you are seeing in here? One of the important things that you are seeing in here is the IP address of a pod. Each pod has a unique IP address. The other thing which you are seeing in here is the 1 by 1, which is the number of containers that are present in that specific pod and how many of them are ready. A pod can actually contain multiple containers. All the containers which are present in a pod share resources. Within the same pod, the containers can talk to each other using localhost. Now let's do another command, kubectl explain pods. What does it do? Kubectl explain is again a generic command. If you do a shift up arrow or shift page down based on your operating system, you can actually scroll up. So what does kubectl explain pods bring us? It says what a pod is. A pod in Kubernetes is a collection of containers. So a pod can contain multiple containers that can run on a host, that can run on a single node. This resource is created by clients and scheduled onto hosts. So what we are understanding is the fact that a Kubernetes node can contain multiple pods, and each of these pods can contain multiple containers. These pods can be from different applications, or these pods can be related to the same application. Now let's go back to the Cloud Shell and execute another command. What we want to do is to get the details of the pod. So earlier we did kubectl get pods to see a high level details of this specific pod. I would want to see this in depth. How can I do that? One of the ways is actually, now I'll copy the ID of this pod. So once I highlight it, Cloud Shell would automatically copy it. What I can do now is to say kubectl describe pod and paste that in. So I'm pasting the ID of the pod in. What would happen now? You can see that it brings in a lot of details about that specific pod. I'll use a shift up or shift page up based on the operating system you are in. You can see all the details. You can see the name of the pod. You can see that the pod has an IP address 10.4.1.3. You can see that the pod is actually running on a specific node, the details of which you can find in here. You can also see that the pod is running in a default namespace. Namespace is a very important concept. It provides isolations for parts of the cluster from other parts of the cluster. What do I mean? Let's say you have your development and QA environments running inside the same cluster. How do you separate the resources of dev from the resources of QA? One of the options is to create separate namespaces for QA and dev and associate each of the resources with that specific namespace. For now, let's keep things simple and stick to the default namespace. Now, what else does a pod have? You can see that the pod has labels. We are attaching a label called app is equal to hello world REST API with this specific pod. Earlier, we talked about a number of concepts. A pod, a replica set, a deployment, a service. In Kubernetes, the way you link all these together is by using something called selectors and labels. So labels are really important when we get to tying up a pod with a replica set or a service. We'll talk about it in further depth. Now, the other things that are associated with the pod are annotations. Annotations are typically meta information about that specific pod. What was the release ID? What was the build ID? What was the author name? And all that kind of stuff are what are put into annotations. And the last thing that you see in here is something called a status. This pod is currently in a running status. The important thing that you need to remember about pod is a pod provides a way to put your containers together. It gives them an IP address, and also it provides a categorization for all these containers by associating them with labels. At a high level, this is how you can picturize how pods would be running on nodes. On any Kubernetes nodes, there can be multiple pods, and each of these pods can contain multiple containers that are running as part of them. I hope you are having an interesting time, and I'll see you in the next step. Until then, bye-bye. Welcome back. In this step, let's get started with replica sets. If I do a kubectl get replica sets, I would get the replica set which was created for us earlier. You can also get the replica sets details by just typing in replica set. Instead of using a plural, you can also use singular replica set. Or if you're lazy like me, you can even use a shortcut. You can say kubectl get rs and it gives you the details of the replica set. Now, the question is, why do we need a replica set? What is the role that they play? Replica sets ensure that a specific number of pods are running at all times. Over here, you can see that the desired number of pods that we want running is 1. And currently, there is one container in ready status. What I'll do is I'll say kubectl get pods and I'll say -o wide. As we used in the earlier steps, -o wide will add a few more details to the get pods and shows a little bit more information. It shows the node where it is running, it shows the IP address and things like that. You can see that right now there is one pod. Carefully notice this specific ID. What we would want to do is we would want to actually kill this pod. So let's take this ID. It's already copied in, and what I'll do is kubectl delete pod and pass in the ID of the pod. Let's press enter. The pod is deleted. Now I'll say kubectl get pods -o wide again. What would happen? You can see that this pod is no longer present because we have deleted it. However, you can see that there is another pod which is started up, VN7D6. That pod is automatically launched up and it's running. If you give it a little bit of time, like if you give it about a minute for the application to completely start up, you would see that the URL also continues to run. So even though we killed a pod, within a minute or so, our URL continues to work. How is that happening? That's because of the replica set. The replica set always keeps monitoring the pods, and if there are lesser number of pods than what is needed, then it creates the pods. We said we would want one pod running all time, and when it goes down to 0, immediately the replica set looks at it and says, okay, there is one pod missing, I'll need to start it up, and it kicks off a new pod. Now, it's interesting when there is one pod running and we kill it, we saw that the pod is automatically launched up. Now, let's say in a replica set, I would want to have 3 pods or 2 pods. How can I do that? How can I tell the replica set to maintain a higher number of pods? The way we can do that in Kubernetes is by saying kubectl scale deployment. What's the deployment that we would want to scale? Hello world REST API. And what do we want to do? We would want to have 3 instances of it. So I'll say --replicas is equal to 3. So kubectl scale deployment hello world REST API --replicas is equal to 3. Let's see what would happen. It says the deployment is scaled. Now if I do a get pods, let's do a simple get pods. Aha, you can see that there are 2 more pods added in. Who's doing this work? This work is being done by replica set. You can see that right now there are 2 new pods. You can see the age of them, 9 seconds. The older pod which we launched up earlier, it's 3 minutes 3 seconds. So you'd see that within a little while all these pods will be up and running. Just give them about a minute or so. Let's do a get pods, about 40 seconds. Let's see if they are all active. I'll go to the hello world URL. So you would see that B1, VN76, VN76. Cool. Now you'd see a new ID coming up, 5x4VL, and if you keep refreshing it, you'd see that there would be 2 or 3 different IDs that you'd keep getting responses from. So what we now have is more than 2 instances of the application running, and they are also having load distribution between them. Let's not worry about the load distribution part for now. Now let's do a kubectl get replica set. What do we see? you can see that the desired is increased to 3. So when we did a kubectl scale deployment hyphen hyphen replicas is equal to 3, what happened internally is that the replica set got updated to a desired of 3, and what it does is it sees the current was 1 at that particular point in time. It says, okay, I would want actually 3. So it launches up 3 instances. So that's how 3 instances are now up and running. Now, we want to see what's happening in the background. How did this all happen? Let's say kubectl get events. So when I go to kubectl get events, you can review some of the latest events which happen. One of the interesting things is this is not in a sorted order. You can see 38 minutes, 2 minutes 23 seconds, 5 minutes 24 seconds, and that's not cool. We want to see actually the events in at least a little bit of a sorted order, and that's where we can add an option called sort by and provide the creation timestamp. The path to the creation timestamp is dot metadata dot creation, let me get this right, creation timestamp. So when I sort this, I can see the I got the option wrong. Actually it should have been a sort hyphen by, and that's the error. So it's hyphen hyphen sort hyphen by, and now I can see the details in a sorted order by time. So you can see that this is where we kill the pod first, and when we kill the pod, as soon as we killed it, you can see that our replica set has started creating a new pod. Now, after a little while, what we did is we scaled up the number of instances to 3. How did we do it? We used the scale deployment command. And what did the deployment do? It scaled up the replica set to 3. So when we executed the command, it said, okay, we would want 3 instances running, so let's scale the replica set to 3. And what does the replica set do? It would start creating new pods. You would see that all the events are happening in here. Now let's do a kubectl explain replica set. Let's do a shift up arrow or shift page up. Now this is the information that we see. Don't worry about the deprecation part. It's something internal to Kubernetes, so we don't really need to worry about it. Replica set ensures that a specified number of pod replicas are running at all time. That's their duty. When we scale a deployment, what happens? The deployment updates the replica set and says, okay, I want 3 instances. And what does the replica set do? It checks the current number of pods. And if the number of pods is less than what is needed, it would automatically start scaling up. So in Kubernetes, whenever somebody talks about replica set to you, it's all about maintaining the number of pods. So a pod is where your containers run. A pod provides a grouping for the containers, and a replica set ensures that a set of pods, a specified number of pods, are always running. In this step, we talked about replica set. I'll see you in the next step. Welcome back. In the last steps, we understood the need for pods, we understood the need for replica sets, and now let's try and understand why do we need a deployment. Now, let's say I have a specific version of application deployed. Let's call it V1. And let's say we would want to update to a new version. Let's say V2. Typically, what do we want when we are updating applications? We would want 0 downtime. Now, let's check the current status right now. So let's say kubectl get rs. And you can see that right now we have hello world REST API with a desired of 3 and ready is 3. That's cool. And I'll say -o white to see more details. So you can see now the details of the images that are associated with the replica set as well. You can see that currently this replica set is tied to an image in 28min / hello world REST API 0101 release. So this replica set is managing this specific release which is using this specific image. Now I would want to deploy a new version of this hello world REST API. How can I do that? The command to be able to do that is kubectl set image deployment. So what we are doing is we are setting an image to this deployment. What is the name of the deployment? Hello World REST. Oops, let me get it right. Hello World REST API. And what do we want to set the image to? We want to set it to a test image. Before that, we need to specify the name of the container. Inside the Hello World REST API, the name of the container is also Hello World REST API. So we need to actually put that next. So Hello World REST API is the name of the container, and you have to put is equal to here and attach a image name. What I'll do for now is I'll just give an error image path. So dummy image :test. So what am I doing in here? kubectl set image deployment Hello World REST API. This is the name of the deployment, Hello World REST API. The second one is the name of the container. Inside the Hello World REST API deployment, we want to set the image path for the Hello World REST API container to a error. Why am I setting it to an error? We want to see if this deployment would go down. So what would happen if we set something to an error? You make a error while you're deploying a new version. Your application would go down, right? That's what typically happens. Now let's see what would happen now. Let's press enter. Cool. It says Hello World REST API image is updated. Okay, but the error, like the image has an error, right? So does our application go down? Let's go and run the URL. You can see that the application is still running, and you'd be like, if you keep running it, you'd see that you'd get requests from all the current instances. That's cool. So even though we made a mistake with our deployment, we see that the application is still up and running. The old version is still running. That's cool, right? Now let's see what's happening in the background. Let's say kubectl get rs -o wide. Now what do you see in here? What you are seeing in here is two replica sets. So there's one replica set which is associated with Hello World REST API 001 release, which is having 3 instances running right now. And you can see the age of it, right? It's 49 minutes. It's running from long time. And there is a second replica set which has been created recently, about 60 seconds back. And you can see that the image which is associated with it is this. And what's happening with it? You can see that the desired status for it is 1. However, currently there is just 0 in ready. So none of the containers are in ready state. Why are they not in ready state? Because the image has an error. The image path that we have created has an error. If you do a kubectl get pods, what will happen? You'd see that there are 3 pods. All these pods have age greater than 14 minutes, which means these are running for a long time. So these are the ones which are associated with this replica set, the old one. The new one which is created, this is the one which is created. This has an invalid image name as the status. So what Kubernetes has discovered is that the image name which is associated with this specific pod is not really right. And that's why the status for it is invalid image name. If you are interested in the details of it, I can actually copy the ID of the pod and say kubectl describe pod and pass in the ID. So this would show me the details of the pod. The interesting thing is the last step. You can see that I cannot parse the image reference dummy image :test. It's invalid reference format. It says the repository should be in lower case. Let's do a clear and let's run kubectl get events with the sort by passed in .metadata .creation timestamp. What do we see? We see the sequence of events which are happening. So 4 minutes back was when we started the new deployment, and you can see that the deployment has created a new replica set. So a new replica set was created by the deployment, and it said I need 1 instance at the start. And what does replica set do? replica set creates the pod. So replica set says, okay, we need one pod running at this particular point in time, so let's create a pod. And what you are seeing is the pod failed to start up. Let's look at a picture and try and understand what's happening. We had a deployment with a replica set 1 with 3 instances. Over here in the picture we have 2 instances, but in our example we had 3 pod instances which are running, which were tied to that replica set. And this replica set was associated with V1 of our application. And now when we are trying to do a V2 of the application, what happened? We said, okay, create a new deployment. And what did the deployment do? It created a new replica set. So it created a replica set V2, and what it's trying to do is it's trying to launch a pods for that specific replica set. To start off, what the deployment said is, hey replica set 2, start with one instance. And the replica set 2 is now trying to start up one instance of the pod, and right now it's in a failed status. That's where we are. Now let's go back to the Cloud Shell and let's try and update the pod to use a proper image. So let's do a set image deployment hello world REST API. Hello world REST API is equal to, instead of saying in28 min dummy and all that stuff, I would actually give it a proper image name. I'll say in28 min slash hello world REST API colon 0.0.2 dot release. So this is the name of the repository and this is the tag that which you want to use. Make sure that this tag actually matches whatever is present in here for 0.0.2 dot release. You can also copy it down from here. So it's in28 min. If I copy this and paste it in here, you can see that this exactly matches in28 min slash hello world REST API colon 0.0.2 dot release. So let's press enter right now. You can see that the deployment extensions hello world REST API image is updated. And what would happen? This is a successful deployment, right? So let's say get pods. You can see that there are a few pods in terminating status, 3 pods in terminating status, and there are 3 pods in running status, and all the ones which are in running status are the new ones. And if I do get replica set, oops, I should have done RS, it's not RES. Let's do a control C and start it again. This is the replica set which we created at the start of the course with V1. This is the replica set which had an error image associated with it. And now you can see that there is a new replica set where we have 3 desired instances and 3 instances are ready. If you give it about a minute or so and if you start running the application, you'd see that everything is now being distributed to the V2 of the application. So the V2 of the application is now up and running. Now we want to understand what's happening in the background. So what I've done is I've run kubectl get events -- sort by metadata creation timestamp. This is exactly the same command which we executed earlier. This is showing a lot of events right now. What we are interested in is in the last few minutes. So as soon as we said, okay, release the new version V2, what does the deployment do? It creates a replica set. It creates a new version of the replica set for V2 and it says have one instance. So this 44F is the V2 of replica set. So what does the replica set do? The replica set would immediately try to create a pod. If you go further down, a little while down, over here you can see that the pod is created. And what happens as soon as the pod is created? The deployment now says, okay, I have one instance of V2 up and running. I don't need 3 instances of V1 anymore. What it does is it scales down the V1 replica set. The V1 replica set is now scaled down to 2 instances and it scales up the V2 replica set to 2 instances. So what the deployment is telling is, okay, I would want only 2 instances of V1 running and 2 instances of V2 running. So what does the V2 replica set do? The V2 replica set creates a pod. What does the v1 replica set do? The v1 replica set deletes a pod belonging to v1. Now, after a little while, if you go further down, you'd see that the new pod is created. And what does the deployment do? Okay, I have two successful pods for v2 and I have two pods with v1. What does it do? It says, okay, now it's time to increase the number of v2 instances to 3 and decrease the number of v1 instances to 1. And that's what it does by updating the replica sets. So it says v1 replica set have one instance. I'm scaling you down. And then it says v2 replica set, you have more instances. I'm scaling you up, so go to 3 instances. And the pods are created for the v2 instance, and what happens at the end is the v1 replica set gets scaled down to 0 instances, and it removes the last pod which was active belonging to v1. Isn't this an interesting journey? I mean, I really love the amount of feedback that Kubernetes provides through all the commands that are present, and that's the reason why we are focusing on actually executing a lot of commands and trying to understand what's happening in the background. Next time you have a problem with any of these concepts, you can just run these commands and try and find out what's happening in the background and try and make sure that you are understanding it perfectly. So, in summary, a deployment is very, very important to make sure that you are able to update new releases of applications without downtime. The strategy which the deployment is using by default is something called rolling updates. What it does is, let's say I have 5 instances of v1 and I want to update to v2. The rolling update strategy, it updates one pod at a time. So it launches up a new pod for v2. Once it's up and running, it reduces the number of pods for v1. Next, it increases the number of pods for v2, and so on and so forth until the number of pods for v1 becomes 0, and all the traffic goes then to v2. There are other deployment strategies that we will talk about a little later. I hope you are having an interesting time, and I'll see you in the next step. Until then, bye-bye. Welcome back. In the last few steps, we executed a lot of commands and tried to dig deeper into pods, replica sets, and deployments. In this step, let's try and summarize what we have learned in the last few steps. A pod is nothing but a wrapper for a set of containers. A pod has an IP address and it has things like labels, annotations, and stuff like that. Now, why do we need a replica set? A replica set ensures that a specific number of pods are always running. So if you say replica set 3 instances, then it ensures that 3 instances of the pods are always running. Even if you kill one of the instances of the pod, replica set would observe that and it would bring up a new instance of the pod. In practice, you'd see that a replica set is always tied with a specific release version. So you'll have a replica set v1, and that would be maintaining a specified number of instances of the v1 release. So a replica set v1 is responsible for making sure that that specified number of instances of version 1 of the application are always running. Why do we need a deployment? A deployment ensures that a release upgrade, a switch from v1 to v2, happens without a hitch. You don't really want to have downtimes when you release new versions of applications. And that's where deployment plays a key role. There are a variety of deployment strategies. When I'm releasing a new version of the application, I might want to actually send 50% of traffic to v1 and 50% of traffic to v2. Or I would want to actually do something like a rolling update, where I would want to first create one instance of v2, test it. Once it's fine, I would reduce the number of instances of v1. After that, I'll create a new instance of v2. Once it's up and running, I'll reduce the number of instances of v1. And so on and so forth until the number of instances of v1 gets reduced to 0. The default deployment strategy is rolling updates, and that's what we saw in action in the previous step. We'll discuss deployments in depth when we talk about different release strategies in a future section. Think back and see what we are doing. We executed a few commands to launch up a few deployments. and we executed a tons of other commands to understand what's happening in the background with Kubernetes. That's Kubernetes in a summary for you. Some of the concepts related to Kubernetes might be really, really complex to understand. But as with any good tool, as you understand these concepts, once you master these concepts, Kubernetes will be a dream to work with. And that's the reason why Kubernetes is so popular. And that's the reason why Kubernetes is supported by several cloud platforms, almost every cloud platform, I should say, and adopted by almost every enterprise across the world. There is one more important Kubernetes concept that we need to understand. That's a service. And we'll look at that in the next step. Until then, bye bye. Welcome back. In this step, let's try and understand the need for a service. Let's do a kubectl get pods -o wide. You can see that each of these pods have their own IP addresses 10418, 10425, 10419, and the URL that we are executing on the other hand, if you look at it, it's automatically distributing load among all these pods. So if I keep refreshing it, after a little while you'd see that there are responses coming back from other servers as well. Now let's kill one of these pods. What I'll do is copy this and say kubectl delete pod. The kubectl delete can be used to delete any of the Kubernetes resources, a pod, a replica set, a deployment, and we are saying we want to delete a pod and passing the ID of the pod in here. So what would happen? The pod is deleted. It takes a little while, and now you would see if I do a get pods -o wide, you would see that there is a new pod which is started up. You can see that the age of this pod is 12 seconds. So you can see that this pod has a new ID, and the most important thing is this pod also has a new IP address. So the IP address of old pod which was deleted is 10419 and the IP address of new pod is 10410. Now if I delete another pod, let's pick up another pod from the list and delete it. Let's pick up one of the older pods. So let's use this and delete this. And get pods -o wide, you'd see that the new pod is now getting active. So 10411, 10 seconds, actually 4 seconds. That's the one which is starting up. It's in the running state right now. So the older pod which we deleted 10418 is no longer active. You can see that each of these pods, whenever it starts up newly, it gets a new IP address. Now think about your consumers. Do you want to keep giving them new IP addresses? Nope, right? You don't want to give them one URL, and irrespective of the pods in the background, you would want that URL to work. If you look at this specific thing, it continues to work. So if you executed it while the pods are being launched up, while the pods are being deleted and new ones are being launched up, you would see that this service is always up and running. How is this magic happening? This magic is happening because of something called a service. In the Kubernetes world, a pod is a throwaway unit. Your pods might go down, new pods might come up. Whenever I do a new release, there might be several new pods which are created and the old pods completely go away. Irrespective of all the changes happening with the pods, we don't want the consumer side of things to get affected. We don't want the user of the application to use a different URL. That's the role of a service. The role of a service is to provide an always available external interface to the applications which are running inside the pods. A service basically allows your application to receive traffic through a permanent lifetime IP address. Now, when was this service created? This service was created when we did an expose deployment. Earlier in the course, we executed kubectl expose deployment hello world REST API hyphen hyphen type is equal to load balancer hyphen hyphen port is equal to 8080. This is when this service was created with an IP address, and that's the IP address that we are using to access the application. Now let's go to the UI and let's go to the service and ingress. This is the service that we have created, Hello World REST API. Status is OK, type is load balancer, and it's load balancing between whatever pods are active at that particular point in time. You'd see the endpoints in here. If you click this and go in and further scroll down, you can see all the labels associated with it. You can see the deployments which are associated with it, Hello World REST API, and the pods which are running right now. You can see that these are all the pods which are serving the requests for that specific service. Now, how is this specific service implemented in Google Cloud? There is a Google Cloud load balancer which is created. So if you search for load balancing and go to the network services load balancing, you'd see that there is a specific load balancer which was created for this service. So let's click that, and you can see what are the things that are in the front end. So this is the URL that we are making use of, 35.223.169.37. You can see that this is the same URL that we are executing in here. So that's the front end, and in the back end we have a number of things. So this is the load balancer which is getting updated as we create new pods, which delete pods, everything gets updated as the back end. However, the front end remains the same. The same URL, same port, will be able to access the application irrespective of how many pods are running in the background. In summary, a service allows your application to receive traffic through a permanent lifetime address. A service remains up and running. It provides a constant front-end interface irrespective of whatever changes are happening to the back-end, which are all the pods where your applications are running. The great thing about Kubernetes is the fact that it provides excellent integration with different cloud provider specific load balancers. We were using a specific type of service called load balancer, and we saw that a Google Cloud Platform load balancer was created for us. That shows how well Kubernetes is integrated with Google Cloud Platform to create a load balancer. If you were working with AWS or if you are working with Azure, then that cloud provider specific load balancers would have been created for you as a service. Let's go to our Cloud Shell, do a clear and run kubectl get services. This would list all the services that are running right now. You see that we have a service load balancer type of service, Hello World REST API, that we are working with right now. A load balancer can load balance between multiple pods. Now, the other type of service is a cluster IP service. Over here you can see that the Kubernetes service is actually running as a cluster IP service. Now, what does the cluster IP service mean? A cluster IP service can only be accessed from inside the cluster. You'll not be able to access this service from outside the cluster. You can see that there is no external IP for this specific service. So if you have any services which are directly consumed inside your cluster, you can have them use a cluster IP. I hope you're having an interesting time, and I'll see you in the next step. Until then, bye-bye.